Ionic wind is created when you shoot electrons from one place to the other. The electrons collide with the air molecules that are projected in this direction. If you take this simple design and you stack a bunch of wires in tubes, you can actually get a pretty decent fan. But all of this kept me thinking, what if I try to turn this bladeless fan into an ionic thruster? If I want to turn this into a jet engine, I need to change the design into something that is actually able to focus the flow of air. And a good starting point, it's a simple cable and tube. The electrons push the air into the tube and generate a flow of air inside the tube. This design is not bad, it's decent, but there's a problem. This is a high voltage transformer you can get cheaply at Amazon. You can apply about 5 volts to this end and you get thousands of volts on the other end. This causes the electrons to jump from one side to the other. As you can see, this discharge is not the same as the other one. That's because the first one is called the corona discharge, and this kind is the one that generates wind. The other one does not. With the cable in tube, I get a lot of sparks jumping when I increase the voltage a little bit. The edge of the tube is too sharp, and the distance between the wires in the tube is hard to control. This is another design. For the negative pole, I'm using a nickel strip that I bent around the tube and glued. Then I used a regular pair of scissors to create some spikes. And that's important because on the negative side, you want a pointy thing. On the positive side, you actually need the exact opposite, a very roundy, smooth surface, just like this metal ring. Because of the round ring, this design doesn't spark with a higher voltage, but also doesn't put out as much air because it doesn't have the tube to focus the air. I think the best solution is to combine both designs, a tube with round edges. This transformer has a lot of epoxy resin to protect the circuit, what makes it heavy. I even tried to use sulfuric acid to remove the epoxy in hopes of getting some of the weight out of the transformer. The sulfuric acid did a great job. It obliterated all of the epoxy in one day, and it worked. The weight got down, but also I think I destroyed the circuit because it's no longer working. I can't complain about the nickel strip spiky cylinder, that's very light, but the curtain ring is solid metal. I think I can improve on that. I found this process called electroplating, in which you can create a thin layer of metal on top of almost anything, like a nut, a pen cap, or even a disgusting tomato. This works by running an electric current through copper sulfate, which is really easy to find since it's a fertilizer. You can connect the positive to a piece of copper that you dip inside the sulfate and the negative to your part. But here's the tricky bit. The part that you dip inside the sulfate needs to have a conductive surface, which a tomato has not. What you do is you use this graphite spray, link in the description, to paint the tomato. Graphite is conductive enough, and if you do everything right, you end up with a metal tomato, which is still disgusting. Now, why am I talking about electroplating? Well, what if instead of using a solid metal part, I 3D print a light resin part, and then I use electroplating to add a thin layer of copper around it to make it conductive? Let's give it a try. Okie dokie. So everything is assembled. I basically glued the entire design on top of the transformer and I connected everything to a lithium-ion battery and a switch. So let's give it a test. Oh, look at that. At least it's making noise. Let's see if it can put out the candle. Wow, not even a struggle. Let's try to put it farther away. Okay, I guess I'll put it even farther away. Oh, this is new. This is like 40 centimeters of distance. That's insane. This is working pretty well. I'm actually proud of myself. But I need to put this on something to make sure it has thrust. And I think I'm gonna start with a boat. Time for the magic. Oh, it's going. It's going all right. Slowly, but steadily. Nice.
This little thing surprised me, it worked pretty well. But I still have a lot of space here and here, so I think I'm gonna add 2 more modules to see if it goes faster. Let's do that.
This time I used my new CNC machine just because, well, I'm lazy. Anyway. Oh god, this is barely floating. It's going? I think it's going faster this time. What do you think, Katerina? Because I think it was basically the same time.
I was thinking, now that I've created this light design, I could probably try to make something that flies. I think an airplane is gonna be a tall order, especially because I don't know how to build them. But what I could do is try to build a low-cost Zeppelin.
Using helium balloons. Banana!
Moment of truth. I'm gonna try to turn on the switch without shocking myself. And letting it go. There he goes! Look at it!
It's falling a little bit, but it's really hard to kind of maintain it at a neutral buoyancy.